All right. Hi, everyone. So I'm going to talk about functional programming in PHP. My name is Michael,
Let me
and I am coming to you
Russian-speaking
from
people, just an introduction
Kampala,
briefly,
Uganda.
that we have a button to switch between Russian and English, and our next speaker is Michael, who will talk to us about functional PHP. Hi, Michael.
Oh, hi there.
Would you just, before you start the presentation, just say a couple of words about yourself and what do you do, okay?
Oh, right. Right. I'm a PHP developer from Kampala, Uganda. So I basically build and maintain a lot of open source packages. I, tackle the occasional. I undertake the occasional PHP project. Yeah, so that's primarily what I do. So yeah, I develop apps, really. Yeah.
Would you tell us how you came to functional PHP? How did the idea appear?
Right. It basically started with a few conversations with my mentor, or somebody I consider to be a mentor-esque figure. So he brought up the idea, and then I pretty much ran with it. So I looked stuff up. I read a lot of books, everything from category theory to category theory for programmers to books about functional programming in various languages. And I settled on the paradigm once I realized its usefulness and had to change my perspective a bit. But yeah, that's pretty much it.
Okay, great. Thanks. So, yeah, you have the floor and let's listen to your presentation.
All right, thank you. All right, functional programming in PHP. So a bit about myself. I'm a PHP enthusiast from Kampala, Uganda. I'm a functional programming aficionado. I love the paradigm. I'm enamored by it, enamored with it, rather. I recently graduated college. I maintain a bunch of, PHP userland packages and extensions. I recently authored a book about functional programming that I will talk about a bit later in this presentation. When I'm not writing code, I'm usually playing basketball, going to the movies. I'm a cinephile, or playing video games. Fun stuff. Right. So, functional programming. Functional programming is inherently a declarative programming paradigm, which means that you focus a lot more on what you want to do, the actions you want to get done, as opposed to the succinctness of the operations that are involved. And it mandates that pure functions be written. Pure functions don't have any side effects, don't have any side causes, and always return the same output given the same input. Functional programming features the use of expressions. You write expressions on a day-to-day basis. Expressions are basically these statements that return a value. And functional programming is a subscience that is predicated on composition. So functional programming requires you to compose these functions. So to create big apps in functional programming, you compose a plethora of functions that you write. So your programs in functional programming will be composed of all these, of all the functions that you choose to write. All right. Sorry, still working this. All right. So next is, I want to emphasize this, which is FP and OOP, functional programming and object-oriented programming, are not opposing paradigms. So this is not a talk that that is going to impress on you, the potency. This is not a talk that's going to impress on you that FP functional programming is superior to OOP. No, this is not the purpose of this talk. This talk is not going to do that. This talk is basically going to hopefully change, condition you to to change your perspective on things and realize that functional programming is a lot about principle. Right. So, what are the benefits of functional programming? I mean, what do you gain from writing code in a functional programming style? Is functional programming allows you to address complexity in your apps, right? Because functions don't have any histories and are immutable by default. It means that functional programming conditions you to be less reliant on paradigms that require you to write code in a way that you keep track of certain artifacts in your code, right? So functional programming alleviates that. A lot of complexity comes from, remembering a bunch of stuff, remembering multiple assignments, and keeping track of those assignments, which can be very cumbersome. Functional programming alleviates all of that. Most of it, really. There's still a burden that comes to writing code, cognitive burden that comes to writing code, but it lightens that load for you. Functional programming allows you to lighten that load. Functional programming techniques, and this is related to the previous point, they truncate the cognitive load of developing software. So short-term memory, which is working memory, is a valuable finite resource. And FP, functional programming, basically allows you to maximize the fullness of working memory without necessarily putting a lot of strain on the fixed memory quanta in working memory, in transient storage. So it sturdies your intellection, your approach to writing code. So it allows you, by composing functions, by parameterizing things, it basically conditions you to minimize the use of the placeholders that exist inside of working memory models. And this is a very valid point because there's about 4 to 7 fixed quanta memory placeholders in working memory. And so if you fill all of those up with these assignments, say x is equal to 2, y is equal to 3, z is equal to the sum of x and y, then you're really filling up, the quanta in working memories. You're going to have to keep track of all these assignments and all the changes made to these assigned variables. So it's tough, and this is a burden that functional programming allows you to lighten by parameterizing stuff and composing functions. So all of this in PHP, yes, it might seem like a lot. The verbiage can get arcane, it can get difficult to understand, difficult to parse, but it is possible in PHP. Why? Because PHP allows for you to write expressions. You write expressions every day in your life. Is a simple addition operation 2 plus 2. That's an expression. Foo-bar, concatenation, foo.bar is an expression, which, again, because expressions always result in a value, right? Array unpacking and therefore array extension is possible now in PHP 7.4. That is also an expression. Instantiation of a class, creating an object, that is also an expression. So you write expressions on a day-to-day basis. You write expressions all the time. Right, and also because PHP affords you first-class function citizenry. What that means is you can use functions in so many ways, almost like other data structures in the language, right? So you can create lambdas in PHP, anonymous functions really, and call those and use those, right? They can be either they can exist as standalone artifacts in your code, right? Also, PHP allows you to use functions as arguments, right? First-class functions. PHP allows you to write higher-order functions. Higher-order functions are capable of either taking a function as an argument or returning a function as a result of a computation, or even doing both is that's the whole ethos of higher order functions, and PHP allows you to do that, right? You can use functions in other composite data structures like hash tables, as you can see with the multiply operation here. So all of these calls really result in the same output, which is 4, right? Because these are all different ways of performing multiplication, but performing multiplication with multiplication while showing off showing off PHP's first class function citizenry. This is a big deal. I can't stress this enough. First class functions are really, really important in PHP, and a great enabler of the paradigm in PHP. So with everything I just said, you might be thinking that you might need to forget certain things about programming. Is there certain concepts I might have ignored thus far? No, don't forget everything you know about programming. Everything you know about programming is still valid. Like I said at the beginning, this is not a debate. This is not my talk. Isn't supposed to impress on you that that functional programming is more important, is more potent than any programming paradigm that you're familiar with. Functional programming is simply, you can think of it as an enhancement because a lot of it is perspective. So don't forget everything you know about programming. Everything you know about variable assignment, everything you know about class instantiation, basically object creation, expressions. Don't forget that. When you're when you're doing functional programming. So there's functions everywhere in the PHP ecosystem. You have user-defined functions like this. Add, which takes two parameters, returns the sum of the said parameters. You have anonymous functions, lambdas that pretty much can do the same thing, but are great because of their inline value. Inline value, basically, when you want to, if you have a higher order function and it takes the function as an argument, then these are great. These are great for that purpose. Anonymous functions are also great as return values for functions that take functions that return a function. And I'll get to that. But anonymous functions are amazing for inline value because they're inline value. And also class methods. You can't negate these. Like I said, don't forget everything you know about programming. Classes are composite data types, and methods are salient in the composition of your typical class. And these too are functions. They're callable units. They are to be treated as as valid artifacts in functional programming discourse. So yes, class methods count too. Now you have to keep them pure. That's one of the rules about functions and functional programming is they don't you're not required to they're not required to induce any side effects. They're not they're supposed to be written in such a way that they do not suffer from any side causes, right? To keep the functions pure. How do you do this? Let's take an example. You have a global accumulator, and you increment its value with a lambda, right? Now, somebody looking at this might say, hey, there's nothing wrong with that. Problem is, you have a potentially, you have a mutable global variable, which is, the accumulator, this act value that I've set to 0, right? It's mutable, means it can change, its value can change, so that's the side cause, right? That's the side cause that the function can suffer from, is that mutability. And when you run this code is you actually increment the accumulator value. So if I add 3 to the result, of 3 after performing the function invocation, then I get the value 7 because I've affected the global state. I've affected the accumulator variable. So that's the impurity there. That is the side effect. So how do you fix this? How do you mitigate this? You could use a closure. Closure is an anonymous function that gives you access to an external scope. Now PHP conditions you to to use more specificity in the way you access external scope. So the use keyword is very important here and a big differentiator. Between closures and just regular lambdas. So this is one way of mitigating it, where for every addition you get a different result, and you do not change the value of the accumulator. Right? You don't change the value of the accumulator. You get a different result based on the input, and you basically get the addition that you want, right? So that's one way of fixing it. Another way is to parameterize all the things, and that way you can get a function that closely resembles the addition examples from previous slides, which is still valid. I mean, if you set the accumulator to 0, if you create an anonymous function or any function for that matter, set the accumulator value to 0 and perform different invocations, is you get different results, which is ideally what you want. Is you get a result that is specific to a certain input. So that way you're not affecting any global state, right? You're siloing, the results of these operations to the function, which is ideally what you want to do. You get one result for every function input. So that's another way of addressing the complexity that arises from impurity. Every argument input should yield the same output. So this is really a maxim really at this point. So what referential transparency, this is another thing that's very important, is it's a quality of pure functions, which dictates that pure functions, the results of pure functions should be substitutable with the outputs. So rather that pure function calls be substitutable with the outputs. So what this essentially means is when I declare a function to multiply two numbers, and I have two numbers, rather to multiply any number of integers, right? And I supply two parameters, 2 and 2, right? My result should be 4, right? So if I'm able to substitute 4 with that function call to multiply with the values 2 and 2, then that should yield, then that implies referential transparency. That means that my function is pure. It's really a barometer. It's a check for purity. It's a nice little check for function purity. Is if you can substitute a function call with its output, then your function is referentially transparent, and you've written a pure function. So it's a barometer. It's a test. It's a measuring stick for purity. So what about classes? Like I said, these are very important artifacts. OOP, object-oriented programming, has a forgotten history, and this is something that a lot of people may not tell you. What we do know about classes is that they are composite data types, right? So you can have a litany of attributes and methods. Encapsulation, is one aspect of object-oriented programming. Property visibility, inheritance, creation of is-a relationships. Though I wouldn't really stress that you create. Functional programming doesn't really emphasize the creation of is-a relationships, inheritance. It's still valid, but anyway, yeah. And then polymorphism, setters and getters, all of this stuff is valid, 100% valid. And you can write some nice, clean functional code with this kind of knowledge. However, there's things that we may not know about object-oriented programming. Alan Kay, who's the creator of the paradigm, who coined the phrase object-oriented programming, basically modeled the paradigm after functional programming. But he also modeled it around his vision of computing, which at the time was multiple computing devices on a network, like biological cells that that communicate with each other, right? So there's a message passing API, and you have these immutable objects that really communicate with each other. That was really his vision for object-oriented programming. And so once you know this, then it makes it makes you more aware of the impurities that might exist in certain in many classes that people might write. So for instance, the setter, right? I have an internal attribute, employee name, right? Because it's a class modeled around employees and whatnot. So the setter basically mutates that value, which is something you don't really want. right? You don't, functional programming and, mutability are, mutability is an antagonistic concept in the realm of functional programming. You don't really want that. So, so each time a setter each time you call a setter is you increase the temporal coupling. Is basically you increase the number of dependent ancestor calls, right? And so you probably end up having this long chain of calls, right? When you're writing code in this fashion, which is not a good thing, from a cognitive load perspective. As you can see here, is we create a new employee, Mike, and we set the employee name to Chad. Is basically if you want to proceed with a set of operations on the employee Chad, then we're pretty much cheating, right, by setting the employee name to Chad on the object that was created with the employee Mike, right? So this is not pure because we've internally changed the object. We've altered object fidelity, which is not necessarily a good thing. So how do you fix this, right? Because the cardinal rule of purity still applies, right? So how do you fix this? You either jettison setter altogether, so you keep your objects atomic. You maintain the atomicity of your objects, right? So how do you so you either remove the setter entirely and create a single employee name value for each object. I know it's a tricky proposition, but it basically allows you to silo, to sequester, operations to specific objects. So if I want to work on Mike, I can work on Mike, the employee Mike separately. I want to work on the employee Chad, I can work on the employee Chad separately, right? That's really the ethos of functional programming, is you want atomicity and you want immutability. You don't really want things to change in an impure way, in an inorganic way. That's really, one of the guiding principles of the paradigm, right? So that's one way of doing it. The other way of doing it is to make the setter a pure function. How do you do this? Is you essentially create a new copy of an employee. Is essentially create a new object, which is similar in function to removing jettisoning setter, but similar in function to jettisoning setter, but just a nice little shortcut in case you want to, to create a new object from previous one and keep those two as just different entities altogether. So by essentially cloning it, which PHP routines allow you to do, you can create new instances of an object and basically create new objects and basically silo operations to those respective objects. So it's a nice thing to have. It's a nice thing to do. It's a great way to enforce purity. So in summary, pure functions do not create side effects, yield the same output given the same input, and are referentially transparent, right? So if you cross-check any of the functions, any of the invocations, is you get the same result, substitutable values for function calls, referential transparency, no side effects, no side causes. So pure functions, right? All right. So now it's time to compose the functions. We're heading into territory of creating meta applications, right? Composed of a litany of functions. So if you're chaining, you're composing, which is also another thing that you do on a day-to-day basis, right? So the moment you're chaining functions, you're composing them. So traditionally, you could do something like this, right? Where I can format a message that looks like that. Sofia is a city in Bulgaria, and so you could do this, and this is valid. This is absolutely valid, and this is still composition, right? The problem is it's cumbersome to deal with long chains. So just imagine if you had maybe 3 or 4 other string transformation functions, right, in a pipeline, in a chain. The function stacking would be absolutely out of this world. The boilerplate would not look nice, right? So at that point, you'd probably be operating with a mentality code reviews be down. But this is valid. This is absolutely valid and something you do on a day-to-day basis, right? So to do more complicated things is you might need a helper library, and there's a bunch of them in the PHP ecosystem. And I will highlight one which is going to be used throughout, for the rest of the presentation, which is a library that I built. It's called Bingo Functional. I designed it to be a suite of functional programming utilities for PHP and JavaScript. I recently put together a REPL for the library, so in case you want to do some experimentation, you can do that. But this is the library that will be used, for the rest of the presentation. Right. So onto the point-free style of composition. Why is it point-free? Is because you don't necessarily explicitly mention the parameters that you're using in your function calls, right? So it basically allows you to write seemingly more compact code, right? So I have a string to lower. That's the first operation I want to perform, and then I want to make the first character first uppercase. This is a nice way of doing it. The only problem with point-free composition is it works best with functions that take one argument. So functions with an arity of one. Arity is basically the number of arguments a function takes, right? So point-free. This is really nice. This fits the mold of abstraction and the declarative nature of functional programming. I'm telling you what to do. I'm basically organizing the coherence of my intellection is basically a set of operations that I want to perform. So you might want to consider using the constant keyword for functions, especially those that exist in exist under namespaces, right? So you might have one file where you've declared a namespace acme, right? And you have two functions, add, prefix, and truncate, and you want to use these functions, right? So a nice way to use the point-free style in your code is to consider combining that with the const keyword, right? So that way, when I try to compose it, as you can see in the lower snippet, I can play around with the constants, right? Which will still, call the functions, right? And I can get the same result. I can, effectively trim, the string butler j to just butler, right? Which is the result that I want to get. So some more FP, functional programming sauce to add to your program. Basically, more functional programming patterns to add to your program. Partial application currying, map, filter, and reduce, or fold, which are routines that you've probably seen before for lists, pattern matching, and persistent data structures. So you might have used some of these techniques before, if we're being honest. Like currying. Basically, currying allows you to decompose a function into a series of subfunctions, right? The thing about currying is it is great for deferred function deferred function calls, right? So if at one point in your program you have one argument, say a function that takes two, or in this case 3 arguments, simple quadratic, right? If at one point in my application I have one argument, and at another point I have I have another argument, and then say at the end of some function call I have all 3, the third argument, then I can parse that. I can do that on a piecemeal basis, right? So I still have the underlying operation, which is performing a quadratic equation, but I just decompose that function into a series of subfunctions that each take a single argument, right? So currying is great if you want to defer function calls, right? It's a really nice approach to doing that. And then you have partial application, which is similar to currying, but in this case, you're decomposing functions that have you're decomposing a function into functions that have variable arity. So if you have, like, the quadratic takes 3 arguments, right? Say I have 1 argument available, and I have the other 2 available at once later in my program. Then I can parse the 2 arguments, as opposed to currying, where I need to pass just 1 argument to each subfunction that I've created, right? So it's another great alternative for deferred function calls, and something that I strongly emphasize that you consider using. Also, There is, one second, wow. Oh, yeah, there's map, filter, and fold. Basically for working on lists. Map allows you to transform values in a list. Filter basically allows you to return a set of values based on a Boolean predicate, right? And then fold basically allows you to flatten your list into a single value, right? So these are all really good, and these are all really good functions for list operations, and they basically allow you to basically they happen in a single iteration. So you shouldn't worry yourself about performances. This all happens in one single iteration. These are highly composable too. So yeah, that's another perk. And then there's pattern matching, which has native support in pure functional programming languages, and useful whenever data has discernible patterns. You could have very simple patterns, which could be a word, could be a number, could be could be a word, a number, even a letter, right? And then you have more complicated patterns, which like a URL, or URI, which is separated by by a bunch of forward slashes, right? That's a more complex, more tree-like pattern, right? So pattern matching basically affords you more succinctness, more specificity with handling situations around patterns, right? Basically transforming data based on the patterns that it has, right? So the good thing about the way it's packaged and delivered in PHP is because it comes with helper functions, is you can it comes with these with helper functional libraries like mine, is it basically allows you to it's basically composable, so you can compose pattern matching as a function, and still get similar results to when you wouldn't necessarily compose pattern matching. So yeah, it's especially great for flow control and a nice alternative to the switch statement for that purpose. More robust alternative to switch statement. And then you have immutable lists, right, which are persistent data structures that create new copies of new copies of list data on each transformation. So again, with the ethos of persistence, right? Whenever you have a persistent data structure, it returns a new copy. So if I create an immutable list with values from 1 to 100,000, right? Oh, okay, wow. Sorry, I just went haywire for a second. I'm sorry. So if you have a list values from 1 to 100,000, and you filter it, you create a new list. You try to square the values, you create a new list from that. So that's the ethos of persistence, and that's great for functional programming because you want to return new copies of objects. So real world I/O is messy, right? So everything I've discussed thus far is really simple functions that play around with strings, play around with integers, play around. You're not always going to play around with data which is inherently that simple to manipulate, right? And so, the real world is messy because many operations are inherently impure. Exceptions are impure. And I/O can get complicated for a number of reasons. As you can return, you can get mixed results, so capricious values, capricious return types. There's potential mutagens, many side causes, potential side effects. So I/O is a very, very messy place to be. So impure I/O operations include file system interaction, writing to and reading from standard input and output, basically console related stuff, opening windows, database interactions, printing to the screen is an impure operation. So you're going to work around these a lot in the real world. Exceptions are inherently impure and not good for function chains because they don't return a value, right? So let's say I'm trying to generate numbers in the Fibonacci sequence. If I try to generate a Fibonacci number that corresponds to a value greater than 20, then I get an exception. I don't get a value. So I've strained the runtime. There's no purity there because there's no referential transparency. I can't I can't really substitute the exception with a value. So that's impurity. So how do you cope with this? Is you use functors and monads you can parameterize, though you might have to deal with callback hell. You can use composition with forward function chaining. Again, going back to the use of functors and monads, and you can use persistent data structures, right? So a functor. Again, we're probably entering complicated FP speak, but a functor is simply something you can map over, right? So it's typically a type class, right? Which is a type of category, a type of algebra, a composite data type like any regular class, and it supports forward function chaining because of the map operation, right? You can transform the internal state, with each map operation. What about a monad? A monad is a more succinct functor, right? It provides more ad hoc value, as we will see later. Is you have monads for handling input-output, for state, for handling global configuration. These are also good for flow control because they're inherently functors. So they have, in addition to operations that are specific to them, the map operation, which just makes composing stuff a lot easier, right? And forward function chaining. So real world monads, you have either and maybe, which are some types, IO, state, reader, and writer, right? So I'll start with either and maybe and either, which are good for error handling because they're composed of these two subtypes. They are algebraic data types. Algebraic data types are, you could think of them as types composed under a single interface. So at runtime, a maybe monad evaluates to one of either a just or a nothing value. A just being the value you want to mutate, and a nothing value being null. It's a unit type. You don't really want that, right? So this is a great alternative to exceptions because this allows you to, maybe monad allows you to specify nothing value where you'd otherwise have an exception, which is not referentially transparent. And then you have the either monad, which works like the maybe monad, which is composed of left and right types. The right value is really what you want to mutate, the value you want to gracefully mutate, and the left value is basically error value. So it's more succinct because you can assign anything to your left value, to your error value, as you can see here with 0, right? If you run this code with 0 is the default for any errors. It's great for the railway pattern, which basically conditions you to write two-track functions for errors and functions for operating on a value inside of a monadic context, right? And then you have the IO monad, which is great for IO-related tasks, rather. So always encapsulated inside the monad is an executable function. Executable functions, like I said, can be impure. Could result in side causes, could result in could be affected by side effects. Rather, could be affected by side causes and could create side effects. Now the thing about the IO monad is the beauty of it is you wrap all of that inside of an object, inside of an algebraic data type. So that's the utility of the IO monad. So in this case, this is a very simple console example that allows you to print the contents of a file to the console, right? And then you have a state monad, which is great for allowing you to perform operations on an initial state and retain both the transformation, basically the mutated copy of the initial state, and the said state. So I have in this case on and val. So every time I specify a value to the add operation, right? I change the state, right? So if the value is less than 0, then the on value will be set to false, but I'll still be able to retain my base state, which is on false and value 0. So the state monad is really nice if you want to work with an initial state and retain copies of the transformed version of that state. Reader monad, which is nice for global configuration. So if you want to play around with global configuration, you can use the reader monad. It's akin to state monad in some ways, but more akin to dependency injection, which is something you do in object-oriented programming a lot. And then you have the writer monad, which is great for logging data. Depending on how you use it, you can be able to create simple event source models with it, because you're keeping track of a log for every transformation. So for every transformation, say I'm adding a number, I'm having a number, is I can keep track of every transformation, which is added to a separate state. It's stored in a separate data structure. So this is another great tool that you can use to address the complexity of real-world apps. All right, so how do you know that you're doing functional programming right? Is your functions should have the following qualities: is they should be pure, they should be referentially transparent, they should be composable, which is really important. And again, depending on the vagaries of the underlying circumstances, is they should give you some aura of conciseness. They should be specific. Specificity aids in composability, because that way you can specify what you want to do, right? So, and you can enjoy the abstractness of the paradigm. Right. So before I conclude, is the future looks bright for functional programming in PHP. Why? Because there's new language features like the new lambdas, the new single line lambdas, right? That are different from regular lambda functions, the single line return functions. These are really nice. Basically condition you to write more functions, right? And then you have new RFCs, right? There's an RFC on partial application. There's an RFC on immutable classes, which means that people are familiarizing themselves with these concepts. There's new libraries. There's more explanatory material, books and such. There's all around language consistency. PHP will continue to support first class functions. Allow you to write more expressions, and so I don't see this changing. So the future looks bright for functional programming. And lastly, before I close, my book titled Functional Programming PHP serves as additional elucidatory material, provides additional elucidatory material on the paradigm. So if you want to learn more about functional programming and how to go about using it in your apps, then I highly recommend this material. So that concludes my talk. Thank you so much for being in attendance. Thank you. That'll be good.